Hey class. Okay, so before we get started on today's lesson, let's do a review from last week. Take about 5 minutes to go ahead and go over that from last week. All right, so last week, guys, you guys talked about transformations. Now, let's look at number one. We know just from looking at the first function, we see that we have a 1 right here. If you're adding a number onto the parent function, you know you're going to be shifting up or down. In this case, where you're shifting up because it's positive. So we know the first transformation is shift up. Okay. Now, next transformation is going on is we're adding or subtracting to the exponent. That's this piece up here. Let me change the color. That's this piece up here. Okay. So what we always told you, they told you from last week was do the opposite of what you see. So you see a negative, you think to go left, but you're actually going to go right. So think of opposite, shift right, okay, by 5. All right, we know shift right, shift up. Now right here, this number, which we also consider as in front of your base, multiply a number to a base, this means you're either going to stretch or shrink. Now let's look at this number. Is this number greater than 1? If it's greater than 1, yeah, like it is, then you're going to stretch. Okay, let me change the color up. So now we're going to stretch, okay, by 3. Just that simple and easy, okay, guys? All right, so let's move to the next one, number 2. Again, we're adding on to the parent function, which is 2x. So if you're adding or subtracting on, you know you're going to shift up or down. In this case, because it's negative, you're going to shift down. Now, unlike the one we just did in the first one, we don't have a number that is what adding or subtracting onto the exponent, so we're not shifting left or right, but I have 2 things going on up here. Okay, one thing is I see this 1/3, okay, being multiplied to the parent function. Now, the first one was we stretch. Why do we stretch? Because it was greater than 1. This case right here, this 1/3 is not greater than 1, so instead of stretching, you're going to shrink. And remember we said stretching means like a rubber band, getting skinny. Shrinking means you're flattening out, okay, or getting fatter, we could say. All right, now the last thing, and you might miss it, but we're not going to miss it this time, is this piece right here, that negative. That negative means if you see it, you multiplying it times that right there, that means you're going to reflect like a mirror, all right, over x-axis. Okay? All right, so just a quick review of last week. I hope you guys took advantage, all right, not the wrong way, of me not being there last week. But this is just a quick review of what we talked about last week at dealing with transformations. Now today, guys, what we're going to talk about is exponential models. Okay, exponential models. And you see on your paper that you have 2 different types of exponential models, okay? Exponential growth and exponential decay. All right, so we know the first one is exponential growth. And the key thing in this one, all you have to do, guys, is just basically look at if it's adding or subtracting, okay? If it's adding or subtracting. You see to the left that you're adding your R and 1, so that means it's exponential growth, okay? To the right, you see you're doing what? Subtracting, so that means exponential decay. All right, just that easy and simple. So over here we have growth. It means your graph is going to be increasing. And over here you have decay. It means your graph is going to be decreasing, okay? You're going to be decreasing. So over here we have, make sure you pay attention, guys, to these variables over here. You have balance is equal to y. P is dealing with your initial amount, okay? Start value is another way to say it. T is, we know, always time and years, dealing with your exponent. R is the percentage of increase. Now, in this case right here, it's going to be a percentage. It's not going to give you a rate, but it's going to give you a percentage, okay? And then 1 plus R is your growth factor. And then 1 minus R is your decay factor, okay? So let's do some examples real quick, all right? Okay, so first equation. Let's check this out. All right, given equation, y is equal to 15, open parentheses, 1.75, close parentheses to the x. Now, first question is, does this equation represent growth or decay? Just as simple. Let's look at it. All right, 1.75. Now, we know you have 1 plus r and 1 minus r, okay? Let's say my percentage was 75%, okay? I must first, guys, change this to a decimal. So in order to change it to a decimal, I take the percentage sign and take it, 2 points to the left. Give me 0.75, okay? Now we know the equation to the left is considered a growth, okay? And the one to the right is considered decay. So let's see what happens. When I plug 0.75 in for growth, for my R, for growth and decay. So if I do 1 plus 0.75 and 1 minus 0.75, okay? Looking at this, I know I'm gonna come up with two different answers. All right, to the left, I come up with 1.75, which I have up there, and to the left, I should come out with, give me a minute, 0.75 minus 1, and I should come out with 0.25. So, you see a good example, growth, decay. So we know the answer for this one should be, I'm just going to put G for growth, okay? You guys put growth on your paper, I'm going to put G for growth for me, okay? All right, now what is the rate of the growth or decay? What's the rate, guys? We already know it, 1.75, all right? What is the initial value? Now, this is our rate. I told you initial value, same thing as start value, is 15. So 15 goes here, okay? And the last thing is asking us to do what? Evaluate for x. So what does that mean when you say evaluate for x? We're going to do what, guys? What you think? You're right. We're going to plug in 4 for x and do it how we've been doing earlier this semester, basically. All right, so y is equal to 15, 1.75 to the 4th power. So in your calculators, guys, do 1.75 to the 4th power. Okay. Stay at 4. And I got 9.378. And you can go ahead and round it to 9.379, okay? So we have 15 times 9.379. Because you have to do exponents first, then you multiply that times 15. And voila, your answer should be 140.7, something around that number, okay? So 140.7 should be your answer for this one, okay? All right, good job. Let's move to the next one. All right, so the second example, okay? We just from the same one, 1.23. We know we have a 1 in front of us, so we know we're growing. It's a growth rate, so G, growth. What is the rate of the growth of decay? 1.23. Initial value, 25. Now, come down here, same thing we did beforehand, right? Plug 2 in for your x. 25, 1.23 to the 2nd power. All right, let's do 1.23 to the 2nd power. I got, just want to make sure, because I don't know if I got that. 0.23 times, yeah, I got 1.5, okay? 1.5129, but I'm just going to round to 1.5, okay? So now I have 25 times 1.5, and I got something around 30, y is equal to 37.8. Something around that number, guys, okay? So, answer for that one should have been 37.8, okay? Good job. Let's move to the next one. All right, perfect one right here. It's a perfect one. Something you'll see definitely on your test, okay? Private tuition of a state college was $15,000. All right, the tuition has about 7.2% annual increase. Okay, so now reading this, I know either have to be growth or decay. The key word that tells me if it's growth is, you're right guys, increase. So what I'm going to do is write an exponential equation describing the situation. We know y is equal to start value. Where am I starting at? $15,000. Good job. Now, 1 plus, what's my rate? Now let's take this again, 7.2%. Now something's a little different because why? That we have the decimal sign. Now we can see our decimal sign. Still do the same thing we did beforehand. Take this and go 2 times to the left. Boom. Plug a 0 in for my placeholder. So it should be points. I'm sorry. Get my point in here. 0.72, not 0.72. 0.072. Okay? To the what? X. Good job. So that's the equation for that one. Now let's go for tuition by 5 years from now. So now we're just going to do what we did beforehand. I'm going to change this to 1.072. Alright, X, and then for X we're going to plug in 5. Now let's go ahead and plug into our equation, 1.072 to the 5th power. I got 1.4, I have a large number. I'm going to bring it down to 1.42. Just going to bring it to that, times 15,000. Let's see how much tuition will be. Oops, too much, dang it. Alright, let me go back guys, hold on, I did a little too much. 1.072 times, what the heck is it doing? 1.072 times 15,000. There we go. Okay, so I got answer I should have. You guys should have is 25,800. That's how much tuition will be 5 years from now. Okay. Make sure you copy this down, guys. Let's move to the next one. All right. So number 5, a vintage radio was purchased by Grandma Schmidt in 1945 for $16. You have the radio. Know what it's worth. Each year the radio's value increased by 1.4%. Okay, same thing we just did for the other one, right? This is actually again increased, so we know it's going to be growth. Okay, but if you have, let's say for example, you have a decay one today, the same thing. Go by the same thing. You're just going to subtract. All right, for your rate. So y is equal to starting value 16. All right. Now we have my rate 1 plus, because it's increasing, points, because we got 1.4%, right? 1, 2, boom, placeholder. So 0.14 x. Good job. Now let's go ahead and put it to the equation. And now it's something that we see down here. The question asks us, what would it be for 2020? Okay. So now we got to figure out. No, we do not plug in 2020 in for X, because that's not telling me how many years it is. It's telling about how much would the radio be worth in 2020. Not putting 2020 in for my X. So let's figure out how we find that out. All right, so we know just by going 2020, we got to figure out how many years it is between these two. 1945, subtract those two, you should come out with 75, okay? All right, so we're going to plug 75 in for my X. Let's see what we get. 1.014 to the 75th power. Ooh, that's a big number. Let's see what we get. See what we get. So let's put in our calculator, guys, again. We have 1.014. There we go, to the 75th power. Now I have 2.8369, blah, 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 blah. But I'm just going to round this to 2.84 times 16. Okay. Alright. So now we have 16 times 2.84 gives me $45.44. Okay. So that's how much it'll be worth in 2020. $45.44. Alright? Okay, guys. All right, so now finish your practice worksheet, guys. Have a good day, and talk to you soon. Peace.